Hey guys, today we're going to talk about a subject that's near and dear to me and I'm sure interests you to the point where you lay awake at night thinking about it. It's called signal flow. What exactly is a signal and why is everybody in the room laughing when I talk about it? So, all recording starts out at one point or another in an analog state. When a sound wave is emitted from an instrument or a voice or something like that, it causes air to move back and forth. You have compression of air and rarefication of air. This is picked up by the transducer or the microphone and converted to a alternating electric current that is analogous to the sound wave. This signal has to be handled in several different ways, at lots of different levels, and so forth to maintain its integrity. So what we're going to do is we're going to talk about the different gain stages of a signal. We're going to talk about the different types of signal, whether it's balanced or unbalanced. We're going to talk about impedance and probably end up talking a little bit about digital audio too. Let's talk about gain stages. When the sound wave is converted to that alternating electrical current by the microphone transducer, it's at a really, really, really low voltage level. In fact, it's what they call millivolts or thousandths of a volt. If you take a 9-volt battery, stick it on your tongue, you can feel a little tickle, right? If you took the output of a microphone and put it on your tongue, there's absolutely no way that you would feel it. So plus you'd look really weird. So you have this millivolt signal. It's really, really weak, and like lights, radio towers, cell phones, all that stuff can infiltrate this signal and cause problems with it. What you have is your first device in your gain stage is called a microphone preamp. Its job is to take this millivolt signal and bring it up to what's called line level. Line level is approximately 0.7 of a volt. So if you took the line output from a mic preamp and stuck it on your tongue, you'd still look weird and you still wouldn't feel it. However, it's definitely a lot less likely to get corrupted by our nasties out in the air than the mic level signal. So it's really important to keep your cable length short, get that signal boosted up to line level as quickly as possible, that's 0.7 of a volt. That is approximately 1,000 times or 60 dB of gain. So your microphone preamp needs to be a really high quality piece of equipment. Any kind of analog signal processing like analog EQ, compression, delay, etc. generally occurs when that signal has been strengthened up to line level. That way the electronic devices are less likely to impart distortion, interference, those kinds of problems into it since the signal's already strong enough to maintain its own integrity. That is the point where the signal is converted to digital if you're doing a digital recording, or it also is used to feed the power amplifier, which is what runs the speakers. So you have a microphone preamp that brings it up to line level, and then you have a power amplifier that brings it up to what's called speaker level, which at that point, if you stuck it on your tongue, you probably would get a little jolt. Not like the electric fence, but you'd still probably at least get a little tickle out of it. So you get an idea about, you've increased this signal probably 10,000 times since beyond what it originally was when it came out of the microphone. It takes some pretty sophisticated electronics to do that, and you can't do it all in one step. Now, in addition to microphone level and line level, in the middle there is something that's called instrument level. The output from your bass, your guitar, your electric violin, whatever happens to have an instrument level output, keyboards, all of that kind of falls in somewhat between mic level and line level. So you can't just take a instrument level signal and make an adapter cable and stick it right into a mic level. It will have a high level of distortion, the frequency response, and the signal-to-noise ratio won't be the ideal situation. So when you do that, there's a device that's called an impedance matching transformer, which takes that signal and converts it to the right impedance and the right level to actually work with that kind of an input. I've got one of those over here. I'll show it to you in just a minute. Audio signals are transmitted different ways. They use different numbers of wires and different types of connectors depending on the level and the type of signal it is. There's a signal called a balanced signal that uses two active conductors or signal carrying conductors and a ground. One of these conductors has the signal in a positive way, and the other one has it in a polar opposite representation, 180 degrees out of phase, and it allows the microphone preamp to amplify the difference between the two signals, thus canceling out anything that is the same in both. What does that mean, really? Okay, so think about this. If you have a interference like a cell phone or a fluorescent light or something that's putting out a RF signal that might get picked up by your microphone cable, if it gets picked up equally in both the negative and the positive conductor, it gets canceled out by the microphone preamp through a thing called common mode rejection. Therefore, what's called a balanced signal that uses two signal carrying conductors and a ground is the most robust and the least likely to get interfered with by the nasties out there in the world. That's the ideal way to transmit, particularly in high RF type environments or over long cable runs. An easier way and a less expensive way and sometimes more common way of sending signals is to use what's called unbalanced. And it uses only one signal carrying conductor and a ground. Once again, this is a much more susceptible signal and really is only appropriate for higher voltage signals. It does not work well at all at microphone level. Unfortunately, our industry has progressed in such a way that almost all instruments use an unbalanced output. It is at a higher level, so it's a little bit pure signal, but it is not ideal. The type of conductor that can be used for a balanced signal is either an XLR type conductor, which is, if you look closely at it, has 3 different pins in it. A tip ring sleeve, which uses a tip, a ring, and a sleeve, so that's got 3 different conductors on it. So these are the 2 most common types of connectors that are being used for a balanced connection. For an unbalanced connection, they use primarily what's called a 1/4 inch phone plug that just has the tip and the sleeve, so it has a signal and a ground. Another thing to consider about signal is, or gain stages in general, are the impedance of the circuit. Impedance is resistance to a flow of alternating electric current. If you think about running across the field and then you think about trying to run in water, you get an idea about what impedance is. It drags the signal down, it slows it down. In an ideal world, we would use primarily low impedance signals, and for microphone type situations, almost always the impedance is low and the signal is balanced. This makes it so it's less likely to have interference and distortion and allows for that really low signal to be as strong as it possibly could. By virtue of the way that pickups are designed, most instrument outputs are at a much higher impedance than what the microphones are. And then if you go to a line level, it's even higher yet. So if you think about a microphone, most of them are somewhere between 250 and 1,000 ohms. If you think about a instrument pickup, around 10 to 25 or 30,000 ohms would be the range that they would have. And then when you look at a line level input, it's usually 100,000 ohms or so. So you get an idea about what the difference in the impedance is. If you try to take the wrong impedance and put it into an input, that's not suited to it, you'll end up with frequency response loss, distortion, less signal noise ratio. However, there are ways to convert impedances and balance signals. Right here we have a handy dandy little device. It's an impedance matching balancing transformer adapter. If you look here at the one end, it has a 1/4 inch input, so you can plug your guitar, your bass, or your instrument right in there. And the other end has an XLR output on it, like a microphone, so you can plug it into a mic input. So this brings the signal down to microphone level, it balances it, and it converts its impedance to the signal to be low enough to be able to plug into the microphone input without causing problems. A direct box does basically the same thing. It has an impedance matching transformer in it. It also has a paralleled output, so you can run off into your amplifier too. That way you can run one signal that's balanced and low impedance to a microphone input, and then you can run the output from the paralleled output into a high impedance input like an amplifier or something like that. So once you've gotten your signal up to line level, if you want to record it in a digital workstation, you need to convert it to a digital signal. This consists of ones and zeros that represent the waveform, which was an analog of the moving air. So it starts out as moving air, changes to alternating electrical current at a low voltage, is boosted up to line level, and then converted to ones and zeros and imported into the computer through your interface. There's different sample rates, different bit depths. Those are all resolution settings for your signal. The standard for CD audio was 16-bit, 44.1 kilohertz sampling rate, which is really very compatible with human hearing. A lot of people are using higher sample rates now, and the reason is when you start processing a signal, if you have more resolution to begin with, it doesn't become as apparent that you've EQ'd or compressed things in the digital domain. Once you get it in there, you can do all kinds of manipulation. There's really a lot of advantages to having that signal in a digital domain, and it's also really unlikely that it's going to get corrupted by RF and things that are out in the world. So it's in a much safer type situation too. So to summarize all this big mess that I've talked about today, I think the important aspect of all this is to understand that you really do have an analog aspect to all audio signals that you're using to record. You have your moving air, your rarefication and compression that is transduced or converted to an alternating electrical current that's very low voltage. The mic preamp boosts it up to line level. The analog to digital converter changes it to ones and zeros, so you can go in there and manipulate it. The digital analog or the D to A converter converts it back to line level, and the power amp or the amplifiers built into the speaker boost it up to speaker level so you can actually hear it. You have a balanced or an unbalanced signal depending on the number of wires in your connector. Balanced is better, particularly for long cable runs. So really, that's pretty much the way it works.